Hello, everybody. Today we are working on Learning Target 6, Make and Interpret a Distance versus Time Graph. So your to-do list today is to watch this lecture and take notes. Step 2 is following a link to Physics Classroom to work on position and time graphs. And then step 3, there's a Google question after you look at a velocity graph. So we may or may not have seen distance versus time graphs before, but our distance is always going to be on our y-axis, and then our time is going to be on our x-axis. All right, our vocabulary word for today, one of them is slope. A related word for slope is incline or gradient or steep. Units would be meters over seconds. And then our equation for slope, you can also say slope equals m, and that is equal to rise over run. And so you can see at the graph on the left here, rise is going up and run is going right or left, so on that horizontal axis. You can also think of it as y2 minus y1 over x2 minus x1. So your y2 and your y1 would be, get my pointer out here, so this would be your y2, this would be your y1, and then this would be your x2, x1. All right, we're going to look at different types of slope now. So positive slope is moving away from home. So you can think of moving away from that starting point down here. And our home is 0, 0. So a constant slope is a constant speed. So we just have a straight line, no curves in it. It's a constant slope. The steeper the slope, the faster the speed. So in this instance, the blue one is going to have a steeper slope because it's a steeper line. So it's going to be a faster speed than our orange line. And now negative slope is moving towards home, so moving down there. Constant slope again is still a constant speed. The steeper the slope, the faster the speed. So this time, our orange line here is steeper, so it's going to have a faster speed than our blue line. And no slope means you're standing still. There's no motion occurring. So no slope is no speed. But you can look here, remember 0, 0 is our home. And so our blue line is further away from home than the orange line because it's farther up. So if this was 0, 1, 2, 3, this is 3 meters away from home, and that would only be 2 meters away from home. All right, I'm going to switch here to OneNote. If I can find my mouse, there we go. All right, so let's take a look at this graph here. Let's interpret it. Let's talk about what is happening at each segment of the graph. So we can see here that it's from segment A to B, we are moving away. We can also calculate our speed because it's going to be our distance divided by our time. So 10 divided by 1 is equal to 10 meters per second. Now, our second segment here, B to C, what's happening here is we're at rest, right? Because there's no slope, no motion is occurring. So we are at rest. Now from C to D, we're moving away again from that starting point. And we are able to calculate the speed again. So our distance is 30 meters. We went from 10 to 40 meters, so that's 30 meters. And our time, we went from 2 seconds to 5 seconds. So that's 3 seconds. So 30 divided by 3 is 10 meters per second. Now one more segment here from D to E. This time we're moving towards the starting point. We can calculate this speed as well. So we go from 40 to 0, so we move 40 meters in 1 second. So that's just 40 meters per second. All right, so now let's do a graph together. Let's create a position and time graph. So one thing I want us to know, our starting point here is 0, 0. And we're going to end up at our stores at 10 meters for this scenario. So at 0 seconds, Jen gets in her car and drives towards the store. So this is our first point, 0, 0. At 2 seconds, Jen is halfway to the store and she realizes she forgot her money and returns home. So what we can see here is at 2 seconds, she's halfway to the home. We know that our store is at 10 meters away. And so she's going to be at 5 meters. That's halfway to the store at 2 seconds. So we put our dot there. And now at 4 seconds, she gets her money and she drives to the store. So at 4 seconds, she got home and got her money. So we're back to a position of 0. Now at 6 seconds, she parks her car and does her shopping. So at 6, she made it to the store. She's over here at the store at 10 meters. She does her shopping for 2 seconds. So that means no motion is occurring. She's still 10 meters. And at 8 seconds, she returned her car and she drove home and got home at 10 seconds. So we know at 10 seconds, she made it home. So we can draw in our lines to make our graph. Here to here to here. So we can also label these parts of the graph. So let's label where the car is moving away from home, back home, or not moving. So we know here she's moving away from home. Here she's moving back home. Here she's moving away from home again, right? Because she got home, got her money, went back to the store. Here she's not moving because she's at the store. And then she moved towards home. So we can put back. We can also note which slopes are positive, negative, or 0. So here we know we have a positive slope. So we are going away from home. Our next segment, we have a negative slope because we're moving towards home. We're moving away from home again, so we have a positive slope. Here our line is straight, so we have no slope, so 0. And then we end with our negative slope on our way home. All right, so that's going to be it for our lecture today on understanding graphing and slopes and getting some practice with our position and time graphs. So now you can go ahead and work on step 2.